These are our results for analyzing frequency response man. In our search for the ideal mass spring damper system, we debated many models: a swing, a car, a horse, and an elevator. But we were convinced to analyze a man, Dr. Yusevich. Upon observation, we decided that Dr. Yusevich is a mass with one spring and one damper. In this video, Dr. Yusevich runs super fast, and we plot his shoulder as a response by freezing each frame and gather shoulder and ankle position data.
Here's our depiction of our ideal model, Dr. Yusevich. As we tried to model him, we determined that if we didn't make a couple assumptions, that our equations would be too difficult to model. By making some assumptions, we ended up with this free body diagram and these equations of motion, giving us a second order system. Our first assumption was that we modeled Dr. Yusevich's body as a single mass, neglecting the mass of his head and his arms and his legs. Our second assumption was that each of his legs has the same K and B value. And our third assumption was that Dr. Yusevich's feet will always have 1 foot on the ground, so we can model this with a forcing function being pushed up from the ground.
This image helps in our assumptions that Dr. Yusevich has no head and also no arms and no legs, but instead just a spring and a damper.
Using the video that we recorded, we plotted the data of his shoulder and his feet, and they look pretty close to sine waves, but that's not very useful. So we just made them into sine waves. So we were able to find the magnitude and phase shift of each of these functions, as well as getting the frequency of the function.
If you finagle our equation soup over here long enough, you'll find our spring and damping constants for Dr. Yusevich, which plug in and yield some Bode plots, and yield that Dr. Yusevich is an underdamped system, obviously.